Okay, welcome to the May 2024 paper 1H walkthrough of the Edexcel IGCSE. Question number 1, you can just spot that this sequence is 2 less than the 3 times table, so it will be 3n minus 2. However, you could treat it as an arithmetic sequence. First term 1, common difference d, un equals a plus n minus 1d. Plug the numbers in and simplify, and you'll end up with 3n minus 2 that way. The 12th term of the sequence, when n is 12, plug 12 in, you get 77 out. Question number 2, discrete random variable. We know that the probabilities of a discrete random variable was sum to 1. That allows us to construct an equation, 0.2 plus x plus 2x plus 0.26 will be equal to 1. Bring the numerical bits onto the right hand side, collect the x's, divide by 3, you get x. Therefore 2 lots of x will be twice as big, and 450 times that probability gives me 162 students travelling by car. You can, because these numbers are small, just list some factors of 72 and 108, although the danger is that you'll miss the highest one they have in common. There's a few other ways of doing these sorts of questions. Here I've done factor trees and then intersecting circles. You can, with 72 and 108, just realise that 2 cubed times 3 squared is 1, 2 squared times 3 cubed is the other. And then take the smallest power of each factor, prime factor they have in common, and multiply those together. Whatever method you've used, you'll end up with the highest common factor being 2 squared times 3 squared, or if you prefer, 36. Reverse percentages, question number 4, so divide by 1.15 to get 820 kilometres. Interior angle of a regular pentagon, well, with all interior angles of regular shape, subtract 2 from the number of sides, multiply it by 180 and divide by the number of angles. Gives us 108, that goes in there, and then subtract 96, add 108 from 360 to get the remaining angle, which is 156. For 6a, expanding m squared minus 3m minus 40. For b, to solve the equation, I'm going to multiply both sides by 3. I'm going to bring the numerical parts onto the right and the expressions involving n onto the left, and divide by 4. We get n equals 4.5. Question 7, I like to list these in order. B union C, that's anything in B or C or both. And you can see the list in front of you. For part 2, the intersect of A complement and C, that's the stuff that's not in A but and is also in C, in this case 27 and 33. The intersection of B and C is the empty set. That is true because there are no elements that are in both B and C. It's either in one or the other, but nothing in both. Words to that effect that show you understand that will be fine. And lastly, the remaining elements of the universal set that are not in A or C are 23, 25, 29 and 31. For the cylinder on the table, well, the cylinder is a type of prism, so the volume of a cylinder will be the area of a cross-section times by its depth. In this case, its depth is 21. It tells us in the question that the volume of the cylinder is 1,575 centimetres cubed, so 1575 will be equal to the area times 21. And divide both sides by 21, we get the area of 75. Therefore, the pressure is the force, 84, over the area, which is 75, which comes out as 1.12 newtons per centimetre squared. Question 9. Standard form, 35 million for the first one, and then the second one we're adding together 8.2 times 10 to the 5 to 6.78 times 10 to the 6. You can play about with that if you want to, or you can just carry out the calculation. Either way, it's 7.6 times 10 to the 6 is the correct answer. 10a, anything to the power of 0 is 1, so just write that one down. 9 minus 3 is 6, so n is 6. And then simplifying fully, 125, a to the 12, c to the 6. For 11, it's an isosceles triangle, so I can split the base up into a 6 and a 6 along there. To find the length from M to C, we can do Pythagoras on either of the right angle triangles that we have there. They're exactly the same, they're congruent. So M to C is equal to the square root of 9 squared minus 6 squared. 9 is the hypotenuse, of course, which is root 45, simplifies to 3 root 5. Then we add together the lengths that we need. We've got 12, 2 9s, and the 3 root 5 we just calculated, which is equal to 36.7. We can only buy wood in a whole number of meters, so we'll need 37 meters. Times the 37 by 21.5 gives us 795 euros and 50 cents. Question 12, factorise 3y minus 4, 2y plus 1. For B, common denominator, well, the lowest common multiple of 4x and 3x is 12x, so I'll multiply the first fraction, the top and bottom, by 3, and the second fraction, the top and bottom, by 4. We'll get a common denominator, add the numerators, 31 minus 14x over 12x. If you've written minus 14x plus 31, that's absolutely fine. For the probability, we've got 3 tenths, 7 tenths, and then 5 ninths, 4 ninths, 5 ninths, 4 ninths. The probability that Harman takes 2 beads of the same colour, so that's either white, white, or black, black. If it's white, white, it will be 3 tenths times 5 ninths. If it's black, black, it will be 7 tenths times 4 ninths. And we'll add them together because we don't mind if it's black or white. And it adds to 43/90ths. Question 14, Abel and Bahira. Well, A plus B will be 15,435. We know that B is going to be 1.45 lots of A. That's a 45% increase. And substituting the B in the first one, we'll get A plus 1.45A is equal to 15,435. Simplifies to 2.45a on the left. Divide both sides by 2.45, we get a to be 6,300. B must therefore be 9,135. And if we times c by 3 over 2, or 1.5, we'll get 9,135. So we can work out c by dividing, and c comes out as 6,090. Question 15, can't be 2 because that would make the denominator 0. For B, the inverse function, I'm going to multiply both sides by y minus 2. Essentially we're making y the subject here when we swap the x's and y's around. Multiply both sides by y minus 2, we'll get xy minus 2x equals 3y plus 1 once you expand the left-hand side. Then we'll get the y's all onto the left-hand side and the non-y's all onto the right-hand side. That allows us to factorise a y out from the left-hand side and then divide both sides by x minus 3 to give us 2x plus 1 over x minus 3. Question 16. At least one sweet of each colour. Well, the easiest way to calculate that is to work out the probability of there being all 3 red sweets or all 3 yellow sweets. Add those together and subtract it from 1. You can see the calculations in front of you. Remember, these sweets are not replaced. Anyway, when you plug it all in, you get 45/76. Decimal is, of course, fine as its percentage. Rationalising the denominator, we're going to multiply by its conjugate pair, so we're going to multiply the top and bottom by 3 plus root 5 over 3 plus root 5. That fraction is, of course, equivalent to 1. Carrying out the expansion of the numerator, we'll get 3 plus 3 root 5 plus root 5 plus 5. The denominator will get 9 minus 5 because the irrational bits will cancel. Simplify the numerator, 8 plus 4 root 5 over 4 simplifies to 4 plus root 5. Question 18, we're dealing with gradients of a curve, so we'll differentiate. Differentiating once gives us 3x squared minus 40. I'm going to equate that to 8 because I know the gradient is 8 from the question. Add 40 to both sides, divide by 3, and then square root, remembering to take the positive and the negative square roots of 16. Gives us plus or minus 4. When x is 4, we can work out y by plugging 4 back into the original equation. So 4 cubed minus 40 lots of 4 plus 1. That comes out as minus 95. And lastly, we need to do exactly the same for minus 4. Plug minus 4 in. Just be careful with your minuses on that one, and you should get 97 out. And so the coordinates are 4, negative 95, and negative 4, 97. Those are the 2 points we gradientate. Question number 19. The first thing we're going to do is calculate the length D to B by using the sine rule on the triangle on the right, the triangle DBC. And so dB over sine 62 is equal to 12.8 over sine 40. Multiply both sides by sine 62, and it gives us something we can plug into our calculator to work out dB. In this case, it's 17.58 something. Then I'm going to dive straight into finding x by using the version of the cosine rule that deals with angles. So cos of a equals b squared plus c squared minus a squared over 2bc. You don't get given that one, but it's a useful one to just know, because on questions like this, it saves a lot of time. Remember to use the answer function on your calculator. And if you do that correctly, you'll get 75.6 to 3 sig figs. Question 20, 60-degree angle in here. So we're dealing with an equilateral triangle, OAC. The three lengths on it will be, I'll call R. The shaded segment will be the area of the sector minus the area of the triangle. So that's 360ths of pi r squared minus a half AB sine C, or in this case a half r squared sine 60. That will be equal to 38. This allows us to work out the radius. So I factorise out the radius squared from the left-hand side. 60 360ths is the same as 1/6, and sine 60 times a half is root 3 over 4. Divide both sides by the multiple of r squared, and then square root it to find r. R comes out as 20.48. And then all that's left is to find the perimeter. So we've got an r there, and then we need the arc length, ABC, which is 60 360ths of 2 pi r. Using the answer function on my calculator again to avoid rounding. When we add that all up, it comes to 41.9 centimetres. Question 21, f of x plus 7 is going to shift it 7 places to the left, and f of x minus 6 is going to shift it 6 places downwards. If you know those, that question is easy. Question 22, bit of a trickier histograms question, this one. We get told that there are 14 adults between 15 and 20, so if I divide 14 by the width of the base, we know that that rectangle must have a height of 2.8. That allows us to work out the scale. Here it's just 1 for each of the large squares. And then finding the area of the other two rectangles, we've got 15 as the base times 3.4, and 20 times 0.4 gives us 51 and 8. Then if we sum together the numbers we know, 14, 51 and 8, and then subtract them from the 100 adults in the whole lot, we get 27 adults that are not represented. So there must be 27 adults between 5 and 15. It's got a base of 10, so I'll divide 27 by 10 to get 2.7. That's the height, and there's my histogram. Okay, removing the hemisphere. It's a bit of a trickier one, this one. We've got the radius of the hemisphere is 2x, the radius of the base of the cone is 5x, and the height of the cone is 6x. We want to come up with an expression for the total volume of the shape, because it gives us the total volume. So 1/3 pi r squared h, where r is 5x and h is 6x. Then we subtract the volume of the hemisphere. Well, sphere is 4/3 pi r cubed, so I'll use 2/3 pi r cubed for the hemisphere, and it tells us in the question that's equal to 6948 pi. Bit of simplifying. Remember to square the 5 as well and to cube the 3 when you're doing this. You can see what it comes out to, simplifying both the expressions. And because we're dealing with multiples of x cubed, we can collect them all together to get 134/3 of x cubed being equal to 6948 after you cancel the pi's. You divide by 134 over 3 and then cube root to find the value of x, which comes out as 5.378, etc., etc. Lastly, we need to find the total surface area of the hemisphere that's been removed. So we need half of the surface area of the sphere, add the area of the circle. So that's going to be, rather than 4 pi r squared, that's 2 pi r squared for the curved surface area of the hemisphere, plus pi r squared for the actual circle. Comes out as 1090 centimeters squared. Question 24, this is the polygon question, so we're adding together interior angles of a polygon, starting at 84 and going up in 4. The first term is 84, the common difference is 4. Plug it into the sum of n terms of an arithmetic sequence, and over 2 lots of 2a plus n minus 1d. Well, that's going to be equal to the sum of the interior angles of a polygon, which is 180 times 2 less than the number of sides, and that allows us to construct an equation we can solve to find n. And you can see immediately it generates a quadratic. Solve the quadratic and you get 2 values of n. Now, interesting quirk with this question, if you follow the arithmetic sequence all the way up, and keep adding the terms together, there is an angle in there somewhere that will come out as 180 degrees for an interior angle. I'm not entirely convinced that this question is mathematically consistent, because a shape with an interior angle of 180 degrees in it, is that a vertex? Anyway, question's flawed. Quadratic reduces down to n squared minus 49n plus 180 equals 0. Factorizes to n minus 45 and n minus 4. N cannot equal 4 because it tells us in the question that n must be greater than 5. And so we'll take 45 and sum the interior angles of a 45-sided shape, 180 lots of 43, which comes out as 7,740, including that one angle of 180 degrees. Question 25 is completing the square. This time, just got to be careful with the negative. I'm going to write the quadratic in descending powers of x, factorize out the minus 3 from the first bit, just being careful with the minus in there. So minus 3 lots of x squared minus 4x plus 17. Complete the square with x squared minus 4x, and then expand it out. And then lastly, collect the 12 and the 17. I rearrange it to make it 29 minus 3 lots of x minus 2 all squared. Well done if you got that one. Bye.